So today, I want to ask you some questions. The first one is, how do you know when a function is increasing? How could you describe that? How do you know if a function is increasing? I know, I'm waiting for you to answer it. Is this function increasing? Is this function increasing? So, this function is increasing, this function is decreasing. And I can see by looking at the graph. As I read from right to left, the graph goes downhill, that's decreasing. As I read from right to left, the function goes uphill and therefore increasing. Now, some students want to read this backwards, and they say, Mr. Kukla, that's increasing. It's true. If you read this backwards, this is increasing, which is why we're not going to read them backwards. In our society, we read from right to left. So from right to left, this is increasing, this is decreasing. Okay, but I actually want you to tell me how you know a function is increasing or decreasing using the word slope in your definition. Okay? How do you know if a function is increasing? And your answer has to be something that uses the word slope. Can you think of one? I'd love to call on you now and find out. But instead, I'm going to say, when a function has a positive slope, the function is increasing. So a positive slope means increasing. And when a function has a negative slope, the function is decreasing. And functions don't have to be always increasing or always decreasing. Let's take a look, for example, at our dear friend parabola. Right, parabola? Here's y equals x squared, and here's what I notice. This function has negative slopes and negative slopes and negative slopes until we get to 0, where there's a 0 slope. And then after 0, we have positive slopes that get more and more positive. So I'm going to say that y equals x squared is increasing on negative infinity to 0 and decreasing on 0 to infinity. Notice my use of interval notation there. And notice that 0 is not included. At 0, the function is neither increasing nor decreasing. The function actually has a slope of 0. And we said a function has a positive slope, the function is increasing. That's not a positive slope at 0, it's a 0 slope. And we said a function with a negative slope is decreasing. That's not a negative slope there. So my function is increasing. My function is decreasing, going downhill from negative infinity to 0, and increasing from 0 to infinity. Okay? You need these definitions, especially if you're moving on to calculus. Okay. Next thing I want to ask you is, how do you know if a function has as a maximum or minimum. I know when I look at a graph, be it a friendly graph like y equals negative x squared or y equals absolute value of x plus 2, I can see a minimum on the graph. I can see a maximum on the graph. But how can I justify that using my math language? In fact, I want to think about maxes and mins in terms of slope and increasing and decreasing. And so we're going to say a function has a max if it goes from increasing to decreasing. My function goes from increasing to decreasing, or increasing to decreasing. I get a maximum. Okay? A function has a minimum if it goes from decreasing to increasing. So if my function goes from decreasing and then goes to increasing, that's a minimum. If my function goes from decreasing to increasing, that's a minimum. Okay? And so we know a function has a minimum when that function goes from decreasing to increasing. We know a function has a maximum when that function goes from increasing to decreasing. So now it's time to do some naming. Okay? Here's a function. And this is 1, 12. And this is 3, 8. And this is 5, 10. And this is 8, 2. And this is 9, 5. And this is 10, 0. Okay, where is this function increasing? Use interval notation to describe when this function is increasing. Give it a try, come back when you're done, or if you have a question. Okay, so for increasing, we said if my function has positive slope, the function is increasing. So I have increasing here and increasing here. So function is increasing on 3 to 5, union 8 to 9. When is this function decreasing? When is this function decreasing? Well, we said the function was decreasing whenever it had a negative slope. So here, and here, and here. Now, this endpoint, I have a negative slope at that point. So that endpoint is included. And that goes into 3. And now notice 3. 3 is neither increasing nor decreasing. That's why there's a parenthesis there. My next decreasing interval goes from 5 to 8. And my last one goes from 9 to 10. 10 is included because of its negative slope. Okay. And what about maxes and mins? Well, I know that there's a max at x equals 5 and x equals 9 because f of x goes from increasing to decreasing. And I know that there's mins to be found at x equals 3 and x equals 8 because f of x goes from decreasing to increasing. But are those the only mins and maxes? Well, no, actually. Don't forget, this is a max, and this is a min. And so our definition that I gave you on the last board about how to tell if you have a min or a max, that works for all the interior points, i.e. all the points except the endpoints. Okay, so I still want to look and see if the endpoints are maxes and mins. But I can use this justification for all these interior points. You could certainly just look at a graph and say, hey, that's a max, that's a max, that's a max, that's a min, that's a min, that's a min. You should also delineate between relative or local versus absolute or global. Huh? What do you mean, Kukla? Well, I have relative maxes at x equals 1, 5, 9. But I only have one absolute max at x equals 1. So, I think about Mount Lemmon, and I think Mount Lemmon is the highest point in our neighborhood. So it's a local max. But is Mount Lemmon the tallest mountain on the planet? No. Mount Everest is the tallest mountain on the planet. Mount Everest is also the tallest in its neighborhood. So we can have lots of local maxes, lots of relative maxes, but we're only going to have one absolute max. Now, of course, if I make this one be 12, then I have two absolute maxes because they have the same height. Okay? So absolute or global max is the highest of all the maxes, and relative or local maxes are I'm a maximum in my little neighborhood. Okay? We can do the same thing with relative min. I've got a relative min here, a relative min here, and a relative min here. So at x equals 3, 8, and 10. But my absolute min only occurs here at x equals 10. All right? Okay, so let's see if we can do this. We know that functions are increasing when they have positive slopes. We know functions are decreasing when they have negative slopes. We know a max on the interior goes from increasing to decreasing, and mins show up when we have decreasing to increasing. So let me draw a graph of f of x. My f of x looks like this. This point is -2, -1. This is x equals 0. And I've got some graph here. This is 2, 1. So here's a function f of x. And I want to figure out when is this function increasing, when is this function decreasing, where are the mins and maxes, okay? So, what do we see? Well, for f of x increasing, I'm looking for positive slopes. These are negative slopes, there's a 0 slope. Here are positive slopes. So increasing from -2 to 0. Now 0 is not included. There's an asymptote there. And -2 is not included because there's a 0 slope there. Are there any other places where this function is increasing, where this function has positive slopes? Sure, over here I see positive slopes from 0 until 2. So union 0 to 2. Okay? That's when the function is increasing. I can't include 0. I can't write this. This is not when the function is increasing because the function is not increasing at 0 because the function doesn't exist at 0. What about decreasing? When is this function decreasing? This function is decreasing when we have negative slopes. So over here, negative infinity to -2, and over here, from 2 to infinity. Remember, when we talk about increasing and decreasing, it's always in terms of domain, so we're always using x values. Please don't say this. The function is increasing from -2, -1 to 0. And I mark that wrong because I know that increasing and decreasing, we use interval notation. And so when you write this, you're thinking about it as an ordered pair. But I'm looking at it saying that's interval notation because when we talk about increasing and decreasing, we use interval notation. So please, gosh, do not give me ordered pairs. We have to be using domain. We have to be using just the x values when we describe increasing and decreasing, okay? All right, now what about maxes and mins? Well, this goes forever approaching that horizontal asymptote, so there's no min, there's no endpoint. This is a max. How did I know? I know there's a max at x equals 2 because f of x goes from increasing to decreasing. And I see a min over here at -2, min at x equals -2, because f goes from decreasing to increasing, okay? All right, so that's my expectation of what you'll be doing when you're asked to describe increasing and decreasing and maxes and mins. Please, please, please remember that these are not ordered pairs. No ordered pairs. Okay, here's yours to practice with. A nice quartic function. Okay, so I've got -1, -3. I've got 0, 0. I've got 1, -3. This, by the way, turns out to be -√2, and this turns out to be +√2. Okie doke. So I want everything. I want when is this function increasing. I want to know when is this function decreasing. I want to know where this function has maxes. I want to know where this function has mins. Okay? So take a couple minutes to write it out. Don't just say it. I need good notation here. I need good description. I need good answers. All right? And come back when you're done. Okay. So when is this function increasing? Increasing when we have a positive slope. Here's a positive slope. Here's a positive slope. So I'm increasing from -1, not -1, -3, just from -1 to 0. Right? These are not ordered pairs. These are intervals. And when else? From +1 to infinity. Not infinity because this goes up to infinity, but because this way infinity. These are x values. When is this function decreasing? Decreasing all along here and along here. I'm decreasing from -infinity up to -1. Not, see, this is coming from positive infinity, but those are y values. When I say -infinity here, I mean all these x's. For all these x values, the function will be coming downhill. The function will be decreasing. But there's more, from 0 to 1 as well. Okay? What about maxes? Is this a max? No, my function doesn't go from increasing to decreasing. It goes from decreasing to decreasing. That's not a max. Okay? What about here? Well, I go from decreasing to increasing there. So I have a min at x equals -1. And where else do I have a min? Over here, when we go from decreasing to increasing, +1. And if I needed to explain why, I'd say because f of x goes from decreasing to increasing at those points. All right, we did mins, but we still haven't done max. Where's max? Well, max is here. There's a max at x equals 0 because f of x goes from increasing to decreasing. That's the only place on our graph where we go from blue to red, where we go from increasing to decreasing. Okay, so now I want to do something really great because that was easy piece of cake, right? Calculator time! So, y equals x to the third over 3 plus x squared minus 8x plus 6. Ta-da! Here's our function. And I want to know when this function is increasing and when this function is decreasing, and I want to know where the maxes and mins are. So, I can use my calculator to do that. I don't think that light helps at all, does it? Actually, it does. Okay. So I'm going to type in this function, x to the third divided by 3 plus x squared minus 8x plus 6. And I'm just going to try the standard zoom window, so I did zoom 6. And I see some things, but I don't see this up here. So I think I should probably push my y max higher. So I'm going to go to window, I'm going to make my y max go up to 50 in steps of 5. All right, so I see this graph now, and I know that this function is increasing all over here and all over here. So how do I write that? Well, -infinity up to what? Up to this point. How do I find that point? Well, that's a maximum. So I can do second calculate maximum. Hit enter. Remember, bring your cursor to the left side of that maximum. Almost there. Hit enter. Go to the right side of the maximum. A little further. Enter. Do you want to guess? Oh no. Hit enter. And so I can see the x value here is -4. So I'm increasing from -infinity to -4. Union, I'm also increasing from here on. So from some point to infinity. Let's find that min. Let's find where that is. Second, calculate minimum. Luckily, you did your assignment 7 graphing calculator lab where you learned how to do all these things, or otherwise this might be hard. So I'm to the left of that minimum and I hit enter. Now I scooch a little further. I go to the right side and hit enter. No, I do not want to guess. I hit enter. And I get 2.00021 is rounding error, and that's just 2. Okay, so that's where my function is increasing. Now, what about decreasing? Well, decreasing, piece of cake, decreasing happens between those points. So decreasing from -4 to +2. And maximum? Well, where do we go from increasing to decreasing? That happens at -4. So there's a max at x equals -4 because f of x goes from increasing to decreasing. And a min? Well, I see there's a min over here and we determined that that was x equals 2, I see the function is decreasing and then increasing. So there's a min at x equals 2 because f goes from decreasing to increasing there. Okie doke. Excellent. So, how about you try this one? F of x equals x squared square root x minus 4. Please tell me when this function is increasing, decreasing, has maxes, or mins. Okay? Come back when you're done, or if you have questions. In the meantime, I'll type this new function in here. We have x squared times square root of x minus 4. Okay, so if I do zoom 6, I see this. What the hell is that? Huh. Is there a gap? Well, let's go over to the table and check that out for a second. Okay, so I saw 4, and 4 makes sense to me because it's a critical point. So if I plug 4 in here, I get 0. That means the function has a y value of 0 at 4. I don't see this connecting. Guess what? Because it's really, really steeply vertical here, the calculator can't actually draw it. But the graph does exist, okay? So I know that graph goes all the way down to 4. So I don't feel like I have a great viewing window though. So let's see if I can make my y max go a little higher, like 100 in steps of 10, and see what happens. Huh, it doesn't look like a square root concave down, does it? It kind of looks like an x squared concave up. That's an interesting thing, isn't it? Okay. Either way, though, the function is increasing. I see only positive slopes here. I'm increasing from positive 4 to infinity. And I'm decreasing never. Where do I have any maxes? No, I don't see a max. I do see a min at x equals 4. How do I know that's a min? Well, it's an endpoint. The graph doesn't continue below the x-axis. This radical says all the x values have to be greater than or equal to 4. So what I'm really looking at is 4, and then this parabola-like shape. That's a minimum, okay? How about we change this a little, and we do x times square root of 4 minus x squared. Okay, give that one a try. And then I think we'll call it a lesson. Welcome back. Okay, so I need to get this graphed in my calculator. I feel like I can graph this because I know it has zeros at 0 and at plus and minus 2. But you may not be comfortable with that. So let's graph this and say we've got x times square root of 4 minus x squared. Okay? And do zoom standard again. And I see this. And wow, it's so tiny. So let's change that viewing window. We clearly don't need y values that go beyond -3 or +3. Well, that's better, but I still feel like I have all this dead space here. Does the graph stop there and stop there? Well, let's change those x values. -3, 3. I wonder if that would be nice. Okay. So I still see a gap. Well, I want to ask you a question. If I plug in a 2 into this function, 2 squared is 4, 4 minus 4 is 0, square root of 0 is 0, 0 times 2 is 0. F of 2 equals 0. This function has a value at 2. There's no gap. There's a value there, just like negative 2 would have a value. And so my function looks like that. It actually does connect, and I need to know that, because otherwise I'm going to be probably getting this problem wrong. Okay, your calculator has difficulty graphing very steep things. It can't graph them, so it gives up and it leaves it blank. Okay, so in order to find increasing and decreasing, maxes and mins, I know decreasing here and increasing here. I've got a min, I've got a max. This is a max, this is a min. Those are endpoints, and I check them by just observation. Okay, in calculus, we'll have another way to determine whether those are mins and maxes without looking at a graph. But for right now, endpoints I need to check to determine whether they're mins and maxes. But I'm going to find these mins and maxes in order to help me describe decreasing and increasing. So second, calculate minimum. Go to the left side of the minimum. And hit enter. Go to the right side of the minimum and hit enter again. So it looks like my minimum occurs at negative 1.414, which by the way is negative root 2. And wonder where that one is. I wonder if because this is origin symmetry. Look, passing through origin symmetry. So I bet this is going to be positive root 2. Let's just check. Second, calculate maximum. Bring my cursor close to that maximum, but stay on the left side of it. Okay, hit enter. Now I move to the right side of that maximum and hit enter. And no, I don't want to guess, so I hit enter again. And look, I get positive 1.414. So yes, root 2 is the value. This is 2, and this is 2. Okay, so here I've got some ordered pairs labeled. I can say that f of x is increasing on, when is this function increasing? From here to here. Will I write negative 1.414 comma 2 to 1.414 comma 2? Only if I want to get it wrong. Don't do that. Definitely don't do that. Instead, I want to say increasing using only x values. So negative 1.414 to 1.414. I would be really happy to see this to this. I'm less keen on decimal approximations, and if you have to use decimal approximations, always go to 3 places unless told otherwise all year long. That's our rule, 3 places, rounded at the end, unless you're told otherwise. So that's where f is increasing. What about f decreasing? Well, I see negative slopes over here, and I see negative slopes over here. So my function is decreasing from negative 2 to negative 1.414, union 1.414 to 2. The endpoints are getting brackets because I'm decreasing at that point, and I'm decreasing at that point. At this point, I'm going from increasing to decreasing. The slope there is 0. That's not a negative slope, so it's not a place where this function is decreasing. Here, the function goes from decreasing to increasing, a negative slope to a positive slope, so that's a 0 slope there. That's not increasing or decreasing. That's a 0 slope, so I can't include these, which is why I'm using parentheses, okay? All right, and we've already figured out where our mins and maxes are. We said that there's a max at x equals -2, this one, and x equals 1.414 here. Those are our two maxes. We also have mins at -1.414 and at x equals +2. That's a min and that's a min. All right, so let's summarize. I know a function is increasing when f of x has a positive slope. And I know a function is decreasing when f of x has a negative slope. I know there's a max in the interior when f goes from increasing to decreasing, and I know there's a min when f goes from decreasing to increasing. I know I use interval notation with x's only, no ordered pairs, when I'm describing increasing and decreasing, okay? Excellent. You should be able to determine all these things from a graph that's given to you, or if you're given an equation, to pull out your graphing calculator and graph it and use your graphing calculator skills to help you answer the same questions. Okie doke? Excellent. Well, remember, there is, as always, homework. Assignment 9, maxes and mins, increasing and decreasing, and it's here on pages 61 through 65, and you'll find a scan of these pages in your Office 365 Graphing Basics folder. Okay, hope this was helpful. Take care.